Good morning, everybody, and thank you for joining us this morning for this AWS security webinar. Today's session is going to focus on Lambda function security. So we're going to be diving deep into how to secure your serverless infrastructure today, and that will be with Samuel Weymouth, who is a member of the solution architect team and a specialist in all matters related to cloud security.
Good morning, everyone. Hope you're having a good day. Lovely weather here in London. And today, we're not going to be talking about that. We're going to be focusing on Lambda function security, defense in depth, and specifically about perimeter security when it isn't really suitable in serverless environments and what you can do about some of the new risks that have evolved in the serverless landscape. So quickly moving on, stuff we're going to be looking at today will be how the threat model has changed and how risks have evolved in the serverless landscape in the last sort of couple of years. Next, we'll move on to looking at how you manage those risks and how security controls have evolved over time to help deal with the perimeterless network environment. And also, we'll be doing a short review of some AWS partner products that can help you sort of manage some of these risks and show you how security controls have evolved over time. So moving straight ahead, has the sun set on perimeter security? Well, technically, we think the sun actually set on it in around about 2007 with the Jericho project. And this project highlighted how the internet in particular and Internet of Things is changing how the digital economy works, how business value is actually increased as the perimeter is removed from your traditional on-premises networking model. Unfortunately, this also means that as you get increased value, as the digital economy expands and the network becomes less relevant as a security boundary to your organization, it also means risks change, not necessarily get better or worse, but simply change. And so the corporate boundary, the secure perimeter, as we fully understand it, cannot really help us so much with this new environment where we have the Internet of Things. We have microservices-based architectures that want to access the internet to gather data from third-party services that you trust or send data to your customers. So Jericho project, Jericho of course relating to the first city in the world to actually have a city wall around about 8000 BC. So moving on, let's have a little review of where we used to be in both the on-premises security model with the perimeter of networking firewall tools, as well as more traditional cloud architectures. So you might have your customers externally over here and an AWS account. Within your account, you may establish a VPC, and VPCs are great because they allow you to establish a private IP range within the cloud that is for your customer, your data only. We'll set up a 3-tier web architecture with this environment. So it might have an application load balancer of some sort, a middle tier that may contain EC2 instances running traditional applications such as Apache or PHP, containerized applications running on Fargate, or even perhaps Kubernetes. And next we have the data tier, so a traditional 3-tier architecture. And the data tier may have some sort of database caching model, RDS databases for SQL or MySQL, and perhaps a master and slave type environment to give you high availability. There's lots of good ways to secure a traditional environment like this. For starters, we can create subnets where you can set up a web subnet at the front end for your application load balancers, a different subnet for the middle tier, and a different subnet again for the data tier. You can control lots of networking functions here because you can set up routing tables, you can use security groups to control the flow of data between the different hosts or application components in each of the different tiers. Next, you can start adding additional features such as CloudFront, which gives you an element of distribution of content for static content. It gives you AWS Shield by default to help prevent some denial of service attacks, Route 53 for your DNS, and then you can start wrapping it in your AWS security services such as Identity and Access Management, which, as we'll come to, is one of the key services that you as a developer or a security practitioner need to fully understand to be able to protect your AWS cloud environment. You also have KMS, for key management services for doing encryption at rest, AWS SSO for accessing and controlling access to AWS consoles and applications, web application firewalls, and Shield, which we mentioned before, which comes attached to load balancers and CloudFront, and also Shared Advanced for customers with more interesting security requirements. So moving forward, I mean, this focuses very much on the way security used to work in the perimeterized traditional application delivery mechanisms for three-tier web apps. You've got lots of security controls you can put in place. There's the network ones, which we've already mentioned, security groups, access control lists, routing tables, subnetting down your CEDAR range. You can add appliances in there for particular firewall requirements if you need things in addition to security groups. You can install agents on EC2 instances and even hosts that are running containerized workloads so that you can do network intrusion detection and host intrusion detection, all within the traditional boundary of a network infrastructure. Now, is this an effective solution? Yes, it is. But does it work when you start to break down into serverless environments? Well, remember we said the perimeter was kind of dead before. If you look at a new sort of serverless style architecture where you're focusing mainly on cloud native services, your account stays the same, your customers will stay the same. However, and also all the wrapping services, many of which are global services with local delivery in AWS, such as IAM or CloudFront, you'll start to see the tiers are breaking down a little bit. First, you might have API Gateway as the entry point to your applications. You might use AWS Lambda as the tool to actually allow you to deploy your code to implement your microservices. And then your data tier has also changed to be more aligned to the types of data that you're receiving, such as document DB, DynamoDB, perhaps serverless Aurora for traditional structured databases, TimeStream, and of course S3 buckets, which can hold structured data in the form of CSV files and so forth. So the architecture we had in the old days with networks and network controls and perimeter controls in a serverless environment, this largely disappears from the position of the customer's side of the shared responsibility model, because API gateways, you can't load an IDS agent on that. Lambda functions operate under a small Linux runtime, which you can't install an agent on for your intrusion detection or host intrusion detection, or even antivirus. And the serverless databases and data persistence layer, again, those are all managed services. You don't see any host that you can install agents on to do the traditional types of security controls that you may be used to in a perimeter-based environment. You can use Lambda functions within the context of a VPC. This is especially useful for when you want to control the outbound network functions of a Lambda function, so that you can say, well, okay, I want the Lambda function to only be able to access certain websites. And to implement that, you'd get the Lambda function to have a network adapter and a VPC, go through some sort of proxy outbound to be able to do those type of connections. However, generally speaking, most of these services don't really need the VPC at all to run. And the way development is moving towards serverless environments where you get the benefits of automatic scaling, which reduces a lot of risk there, focusing on the development, which speeds up your innovation lifecycle, automated deployment tools such as SAM CLI, CDK, and so forth. You know, the benefits of serverless and cloud native architectures are obvious in terms of your speed of innovation. The drawbacks, if I can say it, is in simple terms, not all developers are created equal. Some developers rely very heavily on tools to automatically generate code. So there may be some risks there, because those code generators, or even tools that are used to generate, for example, identity and access management policies, they don't know anything about your organization's threat model or risk profile, or how you do your traditional security practice. And also coders have a habit of, at least the research has shown, have a habit of doing a lot of cut and paste from GitHub and other code repos such as Stack Overflow, where bad practice can spread like wildfire through a serverless environment, especially when the deployment is fully automated, which allows you technically to be able to do bad practices or insecure security practices at scale. So those are some of the drawbacks around this new serverless architecture. Great benefits, you don't spend time patching operating systems, but downside, bad stuff can move very quickly. So the risks haven't gone away. They've merely evolved, and from a security practitioner's perspective, the traditional controls that you're used to using, firewalls, layer 7 firewalls, network routing, intrusion detection software that's based on agents, SIEM solutions even, these controls need to evolve as well to meet the new risks that you're facing in the environment. The threat service is actually larger, not smaller, with serverless, and I'll explain why, because it may seem counterintuitive. If you have less patching, there's no operating system to manage, you'd say, okay, the threat service is smaller. But it's not quite the case, because you remember Lambda functions in the example I showed you of a simple 3-tier web app. They talk to API gateway, which is mostly about HTTPS and HTTP traffic, normal RESTful microservice style architectures. However, Lambda functions are actually ubiquitous in cloud-native architectures. You may have Lambda functions within a Kinesis pipeline that is streaming data from IoT devices all around the world that may be in locations where they're untrusted or the data is untrusted that's coming from those appliances. You may have Lambda functions automatically triggered every time a file from a trusted or untrusted third party is loaded to an S3 bucket via the SFTP service. You may have Lambda functions triggered by other streaming data, other events within step functions, and all of these Lambda functions are pulling data as payloads from somewhere. Now, in the case of an API gateway, you can manage those risks to a point by putting in place web application firewall and using some of the managed rule sets, especially ones around OS top 10. However, for other risks that are associated with data coming in from all sorts of different environments, maybe S3 uploads, maybe SES emails, maybe notifications that are coming into your environment that trigger Lambda functions, those Lambda functions are not protected by API gateway and the web application firewall. So that means the data that's coming into those payloads, they haven't been scanned. They're not haven't been validated to see if the data is actually real or not. So the threat surface, has it really gotten smaller? Not really. It's actually kind of gotten a bit large as the number of Lambda functions you're utilizing in your environment. Next, with the changing focus towards cloud-native architectures and serverless architectures from the old traditional 3-tier network-based, this means that security practitioners, that's good news because you're not spending your time patching operating systems and checking CVE databases constantly for Linux or Windows patches that you need to put in place for applications or operating systems. This means you've got a lot more time to focus on what the developers are doing. Yes, the developers, how they're getting their code, where they're getting their code. Do they copy and paste it online? Do they pull in third-party libraries from all sorts of different places on GitHub or other open source repositories? The pipeline itself, how do you know where the code is coming from into the pipeline? Who's allowed to authenticate to the pipeline to actually deploy new code? So security practitioners will see their focus change in more cloud-native architectures to focus on that development pipeline and the people, the developers who are doing the work and injecting code into that pipeline. Because remember, it's fully automated now, and very quickly, a bad library or a bad piece of code or an untested piece of code can very quickly flow through dev test and production. And if you haven't got those testing tools in place and those new controls for the new evolved cloud native environment in place, you can get in trouble very quickly and at scale. Last but not least, and I'm going to draw your attention to this a lot as we go through this presentation, is identity and access management in case of AWS Cloud, and more specifically, policies. Policies could be resource-based policies that are attached to buckets or individual resources. They could be inline policies, which can be attached to users or groups, potentially roles. They could be policies that are aligned to roles for role-based access control. They could be security control, service control policies that operate across an account or even multi-account environments to control what services developers are allowed access to. Now, that sounds quite complicated, and it can be, and that's why I say to you, as a security practitioner and as a developer, making sure you become familiar with identity and access management and the policy language, and understanding the concepts of the principal, the permissions and conditions that you can apply to control access to the AWS resources in your account become really, really critical in a serverless environment. In fact, I'd say it becomes your front line of service control rather than the traditional network piece. And I also emphasize this is very much on the customer's side of the shared responsibility model. And we provide you lots of help in the case of identity and access management with training, which you can get through AWS training and certification for free. Lots of managed policies to get you started. But all of these things require you to be very familiar with your application, how data flows through your API gateway, through Lambda functions to your data persistence layer, and making sure you understand the principles and permissions that are applied at each of those layers. Far more important and much more emphasis on that now than there was on the traditional model where you had VPC and the flow of connections between servers and components, which is very easily tracked with tools such as VPC flow logs. So risks haven't gone away, they've evolved. We'll come back to that in a minute. So moving on, we're going to introduce the naive application for a moment. Now, I'll have to get you to bear with me for a moment while I do a quick costume change. I am now a naive developer. For those of you watching the webcam footage in the corner or wherever you like, or not watching it at all if you prefer. So this is an example of a simple application that has gone completely cloud native and utilizes lots of the security features of AWS, in particular identity and access management, which we talked about before, and obviously leverages the shared responsibility model in terms of AWS look after the physical perimeter and patching, all that good stuff. And you can focus as naive developer, which is me, on making cool code that does useful things. So what does naive app look like? Well, as a naive developer of a naive application, it's very simple. I have some static content that lives in an S3 bucket that just has a simple index HTML page. And I can use that page to invoke a bunch of Lambda functions or APIs via the API gateway. Now, these Lambda functions will do a variety of different things that my application needs to run, such as, for example, there'll be some administration features, which may or may not run some commands on the underlying operating system of the Lambda function itself. I might also be doing a bit of writing to a DynamoDB table, as well as reading from a DynamoDB table, so I can see a list of users that have registered with my application. And I might also have an API or a Lambda function that is going to make an external call to a third-party API somewhere out there on the internet automatically, because that all happens via the NAT gateway that's implicit in Lambda functions. And it will pull back some data from that API, whether you trust that API or not. So let's do a little bit of a review of the application, and let's go and see what we can see. So here is my unicorn registration site. Naive application on the internet. Excuse me for not doing the greatest web interface known to humankind. So let's see what my application does. As a naive developer, I want to be able to register users. So I'll register a user here. co.uk and hit submit. And we'll see what we can see. Okay, looks like we've successfully registered a user. We can see an HTTP status code 200. So if you remember from our diagram, that's basically via the API or via an HTML page, which you can see here, through the API gateway and invoking a Lambda function. So that's added a user to our DynamoDB database. So if we do a little click here, we can quickly see all the users that are registered in my DynamoDB database. So just 3 people, or myself, of course, and it's just a simple first name, UID, email, and surname. So that's cool. So user registration works. I can check all the people who are friends of mine who've got unicorns. I can also very quickly, if I need to for some reason, run some sort of code in the underlying Linux container where my Lambda function runs. So I might, for example, just simply execute the command print working directory, and I can very quickly see that up there I've got a result. I'm in var task, which is where my Lambda function is running. Now, any of you who are familiar with Linux will realize that that input field could run pretty much any command, but we'll see how that can be misused later. And also, I can invoke my API via the internet. So I can simply press on OK, and it will go away and bring back a payload, which in this case is not too good. That's a cross-site scripting attack being pulled in from a trusted API on the internet directly. And WAF won't help you out much with that type of environment or that type of use case. So let's just do a little bit of a deep dive on some of those things we've just had a look at. So running that malicious command, a user simply puts some data into the form. It could be malicious. Say, perhaps we put an env pipe grep to AWS. Runs through API gateway. WAF may or may not notice a Linux command like that, depending on how your rule set is configured. And in this case here, we've got a Lambda function that has a piece of code that runs the subprocess.check output command. This is a Python implementation, so if you're familiar with Python. And what it's simply doing is you can pass a command in, it pipes standard to standard out, sets up a new shell, and executes that operating system command. So obviously, if we put in there something like env and then pipe it to grep looking for AWS, we might quickly see, we'd see the AWS secret key and access key that the Linux container is actually running under the identity and access management role. And the implication of that from an attacker's perspective is that anything that's in that identity and access management role in terms of bucket access, DynamoDB access, or other access, using those keys, you may be able to, do things that may exfiltrate data, allow a user, depending on those permissions, to change data in some way. So quite a high risk thing to be allowing your developers to put code into their Lambda function that does things that run sub-processes. Another thing we could have a look at here, and this is one that's more traditionally protected by the web application firewall. However, we're going to inject a malicious payload. In this case, it's a simple JavaScript alert that does nothing particularly malicious, but it proves the point. Pass through API gateway, and in this case, the Lambda function, again written in Python, is going to generate a response to the table.put item. So in this case, I'm doing a put item of create a UUID, first name, surname, and email address. Now, should somebody put in some malicious input like that, you'll find that that malicious input gets reflected into the Dynamo table itself. Now, some may argue, and you'd be quite right to point out, that in this case here, the web application firewall will help protect us because it's going to easily pick up some sort of a cross-site scripting attack like this. But remember, Lambda functions aren't just accessed via API gateway, they're accessed by or triggered by all sorts of events with all sorts of data. If you can imagine for a moment, you're doing Internet of Things type environments and you've got streams of data coming in from appliances out there in the wild, sending in payloads. One of those appliances gets hacked. How do you protect yourself from that data making its way all the way into your data persistence layer, potentially wrecking things? And last one we'll sort of call attention to in this particular case is, okay, a network attack. So calling an untrusted API. So again, some sort of user input, or in our case, it's actually hard-coded to go to a particular resource on the internet. We'll fire up an input, some URL. Lambda function will again do a Python method to do using the requests library to do a post to that URL and grab the response from that API. And depending on the payload that comes back from that API, you may have all sorts of challenges around do you trust the data from that API? How good is the security of the people who are actually hosting that API? So as we can see, three particular key risks that suddenly become a lot more important with when you're doing cloud native architectures, because the perimeter is gone, and the perimeter is the traditional boundary that's used to protect you from some of these things. So moving on, we're going to take a little bit of a diversion for a moment while I do another costume change. And by the miracle of smoke and mirrors, I'm now transformed into a hacker. So let's go back to our little website here that we were looking at before. So as a security researcher, rather than a hacker, I'm very interested in this free unicorn website. So I'm thinking, how does it work? I'll do a little experiment with it. I'll submit some code, say, okay, looks like there's a field input form. It must store some data somewhere, I'd assume. What does this do? Button. That looks like it pulls back the data from some sort of database. Could be SQL, could be DynamoDB. As a security researcher, I don't really know either way. I wonder, well, what's this do here? Looks like that just runs Linux commands on the underlying operating system. So to demonstrate some of those, exploits that we mentioned before, and this is all, remember, this is all down to code on the customer side of the shared responsibility model. This is about the quality of code and the methods being used in your Lambda functions. So if I change this and say, okay, let's try injecting a little bit of script in here and seeing if I can submit that to my website and go, oh yes, I got back a 200. Well, that's useful to know, isn't it? So obviously these input forms, these fields aren't being scanned anywhere, maybe not even by WAF. I wonder if that's impacted, if my friends are registered for the unicorns or not. And well, lo and behold, instantly, as soon as my browser tries to render that page that's pulling back the scan of the DynamoDB, I've just made somebody run a script in their browser. So this is a really good demonstration of sort of a secondary SQL and a secondary injection attack where, the initial attack is not so much aimed at the browser of the person submitting it or whatever. It's actually being stored in a database to be retrieved at a later time and breaking somebody's client. So that's a pretty serious problem because now all the data in my DynamoDB is now suspect. What am I going to do? Replace the whole thing? And then I now know that's a Linux thing. So what other interesting commands can I run? Let's look at the example we did before with env and pipe that to grep AWS and hit OK there. Now, as a security researcher, this is pretty interesting stuff. So in this great big long list of stuff, I can see there's a session token here that's quite useful. I can actually see the region and the name of the Lambda function in here. And most interesting of all is that I can actually see the secret key and access key, which are lurking down in these lines here. So effectively, if I take those items and I replay them against maybe a AWS CLI, I might be able to do things like list the buckets and see what buckets the policy that this Lambda function is running under has permission to see. Remember, Lambda functions, if you're not too familiar with Lambda functions, they have an identity and access management policy associated with them that gives them permissions to see the downstream resources that they should be able to interact with. Now, if you are a developer who kind of likes to take shortcuts, you might go and give power user access or even admin access to your Lambda function because that will very quickly ensure that your Lambda function has the necessary permissions to access the resources it needs to access. However, you don't need too much imagination to realize that making a least privilege policy is probably a good way to go, given the susceptibility of code, malicious code being, or even just badly written code or naive code in this case, being exploitable by different things. So that's interesting there. So what else can we do with this function? So just to emphasize the point, we're going to try downloading a virus signature file to the local environment here. So we're going to pull up the icar test file on HTTPS, and let's just see if we can download that to temp. Remember, Lambda containers are ephemeral. They will disappear eventually, but a lot of developers use the Lambda container or the underlying Linux container for Lambda as a place to run certain binaries that they may have packaged up in their Lambda function. And nothing terribly wrong with that, but you need to make sure that those binaries are not hackable, not breakable, or exploitable in other ways. PDF to text, for example, is a really commonly used binary, which has some issues. So it looks like we can run curl successfully as the Lambda user. So let's see if that actually ls-l/temp, if it actually downloaded anything. Yep, it downloaded the icar virus signature file onto that machine. And then let's have a little look here to see maybe we can, as a security researcher, let's see if we can catch that and see what's actually in that file. And there you go. You've got an icar standard virus signature file downloaded to the underlying Linux container. And how can this be possible? This is all down to the fact that the Lambda function has some methods in it that are very privileged and should be protected. And this very much comes down to the emphasis on, as we talked about earlier, the emphasis on the developer, the quality of the code, type of code, and risky code being put into serverless architectures or into Lambda functions in this case. Because Again, it's all on the customer side of the shared responsibility model. So you need to, as a security practitioner, really focus on what developers are doing inside their Lambda functions. We'll come to some tools to help you manage those risks going forward. So, cool. So hopefully that hasn't terrorized anyone too much. It's just simply calling out some of the things that can go a bit wrong if you haven't got a really good handle on how your developers are writing their code and what code they're putting in. So remember, it's about the developer, their code, the pipeline, and the tools you put in place, and doing the right testing within that pipeline to ensure that these type of untrustworthy methods and code aren't rolling out across your whole environment. So the good news, new security controls for new risks. So we've highlighted some of those risks. We've highlighted some of the challenges and demonstrated them, hopefully quite ably with those particular tools. Let's see what we can do about it. Now, we have a number of AWS partners that have developed tool sets around preventing some of these risks. Protego and PureSec, both companies that are focused on serverless security products. And these are products that deal with the three main forms of attack we saw before: that unrestricted network access that you need to control, the unrestricted access to the operating system commands that you need to control, and also the looking at the flow of data from API gateway or whatever entry point is, Kinesis or an S3 bucket, through Lambda functions to the persistence layer, and actually scanning that to see if that pattern changes in some way because the Lambda function's been rewritten or has different access to different permissions and different resources. Now, moving forward, in the last 18 months, all of these companies have since been acquired by other security vendors that you may be more familiar with. Protego have been acquired by Checkpoint Software Technologies, and PureSec and Twistlock have both been acquired by Palo Alto, both AWS partners and both able to provide you with these new and interesting tools that we're going to have a little bit of a review of now. So there's lots of good news in that space. Now, if we just temporarily go off to have a little look at the one I wanted to draw your attention to today, which is Prisma Cloud. Now, I'm just going to maximize the screen so you guys can all see what's going on. Prisma Cloud is implemented in a couple of ways to protect your Lambda functions. And specifically, if you think about the perimeter, old school perimeter you may be familiar with, if we could shrink that perimeter down until it's totally wrapped up in the Lambda function itself to protect against that network access, operating system access, and the access it has to resources of an AWS, then we've made the perimeter the most granular form we can. And that means that gives us really good protection, because regardless of where event data and information is coming from, the Lambda function itself now carries its own security around with it. And that's the groundbreaking thing I wanted to bring home to you and really emphasize, is that the perimeter is the function itself using these tools. They all broadly work the same way from those three vendors, is that there will be a layer which you need to implement in your Lambda environment. You simply have your Lambda functions reference that layer to access the methods and firewall software underneath it. And you'll have a couple of properties you add to your Lambda function, which we can show you briefly in a minute. You also reference the layer code within your Lambda function itself. So in simple terms, your Lambda function only needs very minor changes: a new environment variable to access the policy engine that will be used to help control these access to these features, such as operating system or network. Inclusion of the wrapper library, or a decorator in the case of Python, to wrap your function's event handler in some code that will help implement the firewall and operating system access controls. That's it. Then you just deploy your Lambda function with that layer. So in fact, we can do a quick demonstration of those exact things. So if we just quickly pop into Lambda here. No, we're signed out, so every demo goes horribly wrong at the first hurdle. By the way, this is the AWS SSO product, which allows you to have different roles and access control, command line arguments, etc. If you want to use the CLI or the GUI, so you can always be logged in with the correct role. I'm going to be an administrator for the purposes of this demonstration. So let's go and have a little quick look at Lambda. So what's changed? From a perspective, and this is from the developer's perspective, not much has changed. Very easy to start implementing some of these new security tools. We have a layer, which in this case comes from, called the Twistlock Defender, which comes from the Palo Alto Prisma Cloud product. That's simply just a layer that's downloaded as a zip file from the Prisma Cloud itself. You deploy it and tell it what runtimes you want it to be able to protect. Very simple, nothing hard about that. In your functions themselves, if we pick on some of those functions that we've deployed as per our diagram earlier, we can simply click on one of our functions here and we can see how that's actually implemented in the code itself. So when the function is deployed, using, in my case, the SAM CLI, we can very quickly see that we've just got a layer added into the function here, and we can see which version that is, which is hopefully the latest one. So we can see that there, and in our function code itself, we can very quickly see that all we've done is we've added in and imported the Twistlock serverless code, which is pulled in from the function, and then just put a decorator in from the Twistlock serverless handler itself. So what does that give us? Well, coming back to the Prisma Cloud, the Prisma Cloud is a console you use to set up the security for your serverless and containerized environments within your AWS account. It actually implements as a Docker container that runs on an EC2 instance, and you can access it basically via an external IP URL, such as this. So moving forward through the Prisma product here, first thing I wanted to draw your attention to is that we can use a thing called the serverless radar. We also have containers radar, but we're looking at the serverless one specifically here at the moment. And we can see that very quickly, it's already explored our environment and worked out that there's an API gateway and there's 5 different Lambda functions we've got running off it. And those Lambda functions are speaking to CloudWatch logs and DynamoDB. So very quickly, we can see that we get an overview from the serverless radar to see what are the ingestion points for data, what Lambda functions are processing that data, and where is it being persisted to. All comes up straight away. And that's just using the automated discovery tool for your Lambda functions within the radar. Now, if we click on any particular function, so click on the administrator function, remember that's a function that allows us to run those particularly high-risk commands at the operating system level. We can quickly see for a particular Lambda function, we can see what its triggers are, its API gateway, version of Python, what region it's running in, the provider is AWS. Prisma Cloud also works with other cloud providers. We can see the permission stack that the function has, so we can very quickly see it's got access to CloudWatch logs through the IAM policy as part of the function. It's got 3 actions: create log groups, create log streams, and put log events. Now, you'll also notice that there's no vulnerabilities in the code that are recorded right at the moment. However, it very quickly throws up that there's some compliance issues with this code. So, and by the way, this is all part of the auto discovery to see these compliance issues and things. It's just part of the function of the Prisma Cloud. We can see very quickly that it's where the function is, version, memory timeouts that are completed with it. We can show the details of what this medium risk is about. And this relates back to, remember I said identity and access management policies were the most important thing in a serverless environment. That's identity, access management. Know it, love it. This function's actually got what was considered to be too broader access to the CloudWatch function. So there's no reason why the Lambda function should be able to create new log streams. You typically create a log stream as part of a CloudFormation script that actually deploys the function itself. But the function doesn't need permission to create log streams, no. And what can you put in log streams? Well, log streams and logs themselves can be a really good way to have data leakage in your environment, because whatever you log is now in CloudWatch and being persisted somewhere, maybe even directly sent out to a SIEM system that has a different security team running with different permissions, and suddenly you're pushing all your logs there. So that can actually be a serious cause of data leakage, and Twistlock quite rightly identifies that as a medium risk. So that's the first thing we talked about. We talked about quality of code, we talked about the identity access management permissions, talked about the quality of developers. This immediately gives you visibility of not only where data is coming from and where it's been persisted to, but the permissions and where the permissions are too broad in your environment. So you immediately be able to start getting that least privilege access figured out. Another thing I want to draw your attention to is that it also links quite cleverly with CVE repositories. So in this case, we can automatically see the third-party libraries. And remember, that was one of the key risks we identified earlier, was third-party libraries being imported into your code by your developer teams, part of that automated pipeline. So we can see here we've got Python, and it's got the requests library and URL lib3 libraries are imported. It tells me what version they are. It also tells me straight away that the requests library, as of today, has got 35 known CVEs against it. So as a security practitioner, I've instantly got visibility of that and can say, okay, there's something I need to review, consider. Maybe we need to have a word with our developers and perhaps get them to, take action, upgrade the version of requests that they're using that's packaged in their code. So very quickly, you can see some of the quality of third-party packages that you're dealing with as well. So moving away from serverless radar for a moment, so we can quite clearly see all our functions. Let's try and find one that's got a bit more of a risky setup here. So our write to DynamoDB function, remember this is a function that will quite happily write, and cross-site scripting attack back into your DynamoDB, which naive developer didn't think about when they trusted that people would only put nice stuff in their input fields. And we can see it's got a different compliance score here. So it's got some high risks. So let's go and have a little bit of a look at these. And again, from a security practitioner's perspective, this is golden information about your security posture in your serverless environments right now. So we can quite quickly see there's a couple of high risks here. What this is telling me is that, again, in the identity and access management policy associated with this Lambda function, it's too permissive. It's got batch writes to DynamoDB. It doesn't need that. So that's an immediate action you can take with your developer team and say, you need to adjust these policies, these permissions. Delete item, why does it need to delete item? It's writing, it's not deleting items, it's a writer, right? Update items, yeah, potentially it needs that, depending on the functions that you want to do for your use cases. And it also has some other high risks here. So these are considered functions that have, in this case, quite clearly identifies data tampering risk versus data leakage risk. Very clear risks your security practitioners and your business can understand, mapped to actual permissions in an IAM policy. So golden information here, because it tells you this business risk is associated with this permission in your identity access management policy. Remember, identity access management, learn it, it's important. So moving on, what else do we have in the Prisma suite that might be quite helpful to us? Remember we talked about operating system access and network access. Well, in this particular case, because we've implemented the code to deploy the what we call the perimeter within our Lambda function itself, this also means that we can now set up rules about what's called a cloud native app firewall, and this allows you to set up rules to determine what things a Lambda function is able to do and block them or alert on them as you wish. So in this particular case, this is just a default rule I've set up that will apply to all the Lambda functions in my environment that are being discovered. And I can just say it's going to alert if this rule is broken by any of the Lambda functions as they execute. Remember, this is runtime protection. So as the environment is live and processing customer data, it's looking for SQL injections, command injections, code injections, cross-site scripting, all sorts of different attacks applied across all the functions that I have in my environment. So already you can see I've got a firewall there that's going to do a lot of the sort of similar roles to what a WAF does, but it's going to do it in the Lambda function itself. And you remember, Lambda functions aren't just accessed via API gateways, they are triggered by any event. So now I've got an injection attack detection and prevention system in my Lambda function code itself, right, using a policy in a centralized console with the Prisma Cloud. So that's my payload protection. What else can I do? Remember, we talked about runtime protection as well. So this is like, what is my Lambda function allowed to do? Can it access the internet? Can it run on commands on the operating system in Linux to pull back those environment variables? Let's go and see. We've created a rule in here which is basically a default route to alert or block on suspicious behavior. So out of the box, you get a bunch of Prisma Cloud Advanced Threat Protection turned on. It applies to all the functions in my environment. We can look at processes, so we can look for specific things such as detection of cryptocurrency miners that may be involved in any of your containers or Lambda runtime environments if things have been installed. You can explicitly allow or block certain processes. So maybe I want to allow ls-l or allow a particular binary such as raw to JPEG or PDF to text in my Linux environment, but I don't want to allow any other processes. I don't want a developer to be able to call the env command or download a file or execute a file or change permissions on a file, all of which are bad things. You can imagine where you'd get to if you had a developer write a Lambda function or accidentally put in place a Lambda function that was capable of pulling a Python script down from the internet and then just being able to run Python -c command, via a subprocess popen. That's bad news. So this is how you block those type of process accesses. Networking, the next one. So in here, I can see that for my given Lambda functions, I can allow specific ports, particular internet ports or listening ports. I can set up whitelists of IPs that the Lambda function is able to access externally, or block it to only allow it to be able to access certain domains. So I can set up an alert, disable, or prevent, depending on how I want to control what my Lambda function is capable of doing. And this is great because, again, you've made the perimeter, the Lambda function itself. You're not reliant on third-party infrastructure or other infrastructure to make this stuff work. So that seems pretty cool. And last but not least, file system access. So this is where you might be able to say, allow a Lambda function to be able to start scribbling all over the underlying file system, the Linux container, such as I showed you a demonstration of downloading a file from the ICAR antivirus file or FitzVirus signature file straight into the temp directory, and then be able to view it, potentially be able to download scripts and then run that using the script as an input for the Python command, for example. So by using this tool, you can start blocking that kind of file system access Lambda functions are capable of doing, and thereby protect your environment from unauthorized activity. And remember, again, key thing to emphasize here, when you look at the naive application that I demonstrated, it's simply a matter of code that can be easily exploited, and you need to have controls in place that are checking that code as it comes through the pipeline, and tools like this that can help you bring that to control what that code can do in the runtime environment. So that's all good news and those sort of things. Again, we can see vulnerabilities that are going to be pulled in and access control for secrets management and stuff in the Prisma console. Now, that's the defend, setting up defend side. In terms of monitor, we can see some events. So we'll start seeing events as we've deployed our controls based on those alerts or blockages we want to see. We can see the runtime environments, vulnerabilities. So our functions here, at the moment, we've got no vulnerabilities registered against our functions at the moment, but that data can change as our functions are used. And we can see the compliance information here, a very simple report that shows us read from DynamoDB and write from DynamoDB appear to have quite high risk IAM permissions against them. So this can help you map your IAM permissions to whatever risk framework you choose, be it the CSI benchmark, or perhaps you like the PCI DSS benchmark, which you can use things like Security Hub to help you manage. This gives you some of that same sort of functionality, but looking more at the serverless space. And last but not least, in the console, there's just a few things you can do around sort of management viewing logs. And the Prisma console has basic authentication by default. However, you can set this up to actually use SAML authentication, so you could access it via AWS SSO. And last but not least, I'll show you the one last thing, is the Defender space. So this is where we actually set up the code that we're going to use to protect our Lambda function. So we give it the name of the console, the Docker container where the Defender runs, the type of Defender we like. So we can set up different Defenders, containers, hosts, serverless, so we can do lots of different things there, which is quite good. You can use the same tool for EC2 and containers and serverless, it doesn't matter. And we're going to know if we're doing a serverless Defender, our runtime is Python, it's going to be embedded as a layer, which we saw earlier, and then you can quickly download the zip file for the layer and simply deploy it. This tells you what code to add to your Lambda functions, and in a later release, you won't even need to add this anymore. Merely the fact you add the layer and will automatically add the handler. And remember we said there's an environment variable we have to put in place. That environment variable is calculated, and it's simply just a base 64 encoded string with information about where your Defender console or listener is based within your AWS environment, so that and what protections and policies you want to enable by default. So that gives you a quick run through of the Prisma Cloud. As I said, the main sort of learnings from this particular demo were around the space of how the threat landscape has changed in a serverless environment. And I did hopefully a fairly bit of a wake-up call demonstration of some of the new risks that are associated with Lambda functions or serverless environments. We did a bit of a look at some of the new tools that are available from our partner networks that help you manage those risks. And that is pretty much all I have. So I'm just going to quickly pass it over. We've been running interactive question and answer as we go along through this session. And I'll just do a couple of brief things that I wanted to cover off in terms of the 3 key takeaways. Takeaway number 1, that risk has evolved. It's not gone away just because you're using serverless. It's just changed. And that means new risks, new threat model, new things for your security practitioners to be aware of, and new things for developers to be aware of as well. I won't show you today, but I can show you some really good research that's been done into the copy and paste culture that pervades some development teams. And because of Lambda functions being fast and easy to deploy and easy to test and very innovative and iterated, all that good innovation and business-driven stuff you want to do for your customers, serverless is the way forward. But bearing in mind, there's not no risk, it's just different risks. And secondly, key takeaway, your tool sets and the way you approach your security controls for serverless also need to change. We've shown you some tool sets that come from some of our APN partners. There are also things like Code Guru within AWS, obviously identity and access management, which is a free part of your AWS account. Lots of free trading available for IAM, and you really want to be familiar with it. And another feature of IAM that's really worth calling out is permission boundaries, which can help control, even where developers are pushing through Lambda functions and IAM policies, part of those applications, you can control and scope down permissions regardless of what the developer may request in their policy. And last takeaway is that these are one of the things or common misnomers is some of these threats or risks have changed with the advent of tools like Nitro, Firecracker, and stuff like that. And yes, Nitro and Firecracker have mitigated lots of risks at the KVM layer and host layer and sharing of data potentially between different hosts. And basically all those risks have been mitigated by using the Firecracker and Nitro tools. However, these particular risks I'm highlighting today and showing you simple examples of, these are risks that are inherently in the customer side of the shared responsibility model because they're in the very code and the Lambda functions that you create. So that code is only as good as the developers, the testing tools, and that perimeter security with a Lambda function perimeter itself. And those are the security tools you have to rely on in a new sort of cloud native architecture environment. It's not impossible to add in some of the traditional controls such as layer 7 firewalls and stuff like that, and we have lots of products like that on the APN marketplace that you can use. However, they are mostly focused on the more traditional network-based control style, and that isn't bringing the perimeter down to the Lambda function itself. Because remember, Lambda functions can be triggered by events from all sorts of different things because that threat service just looks very different now. So those are the 3 key takeaways. Hopefully you've learned something interesting, and hopefully the demonstration didn't scare too many people. And we'll push it over to the Q&A. Thank you, Ross.
Yeah, thank you very much, Samuel. Great presentation, great depth there. I'm sure that was greatly appreciated. Your wardrobe changes were getting a lot of praise online. So
did they? Oh, okay.
Good call on that. So we've got about 5 minutes. So I think I'll try and get through sort of 3 of these. So we'll go for quick answers if possible. So quick question here, just to clarify, are you saying that Prisma provides agent-like capabilities for serverless? which enforces rules inside the running Lambda function?
In a sense, yes. The Prisma code is embedded in your Lambda function, and it makes calls to a policy engine as the code is executed. So as you're sort of, the code is winding through and calling the different methods within it. I'll see if I can show you an example from my earlier slide. Bear with me. Okay, I'll go for this one because I like the OS command one. So where you call a process that's inherently risky, such as sub-process, the Lambda function will, as each line is executing, it will basically be monitored by the policy coming from the policy engine, and the Lambda function will simply be alert if a risky function is called, or block, and that line of code simply won't execute in your Lambda function. So essentially, yes, it's correct to say that the Lambda function now is aware of policies from the central policy engine, which runs as a Docker container in EC2, and basically blocks execution of risky processes. And you can define those processes that are allowed or not allowed in policy within the Prisma engine itself. Hopefully that answers your question.
Yep, good stuff. So the next one, another good one. So given that organizations don't have to do patching when they're running serverless workloads, how does AWS address patching of the infrastructure and the Lambda environment, essentially? And is this documented anywhere?
Well, AWS implements a rigorous testing and patching regime, which you can read about in AWS Artifact. And if you've got an AWS account, Artifact is a service that allows you to pull down documents such as our SOC reports, which are our how we do security operations within the AWS environment. And this gives you details of testing, both of, we essentially AWS write APIs. So we're testing that code all the time and doing really in-depth security testing and validation to make sure our APIs that are out there on the internet for you to use are as secure as they can be. And so we do that kind of pipeline for code delivery, testing within that pipeline to ensure that the code is safe at every possible point. We even have a group called the Automated Reasoning Group. They're actually validating that our code actually does what it says on the tin in terms of how are we logging, how are we meeting the regulatory requirements that we need to meet, such as GDPR. So to answer your question, yes, we do rigorous testing of our environments, and that is publicly available information. So whether it be SOC or ISO 27001 or just general information in the public-facing documentation, we do a lot of information about how that works. So you can download that for free at any time you like.
Okay, very good. And we'll go for just one more. So the question reads, I thought every time a Lambda is run, it runs in its own enclosed container. How are you able to access the same Lambda container for all commands?
Lambda containers, in order to speed up the execution of Lambda, you don't necessarily get a fresh new Linux runtime with every single execution, because that would involve having to spin up a new Linux machine, deploy the code on it, execute the code to be able to respond to the event that you've done. So the same container will perhaps rerun one or multiple versions of the Lambda function, and that's how Lambda is actually able to scale up. So the same Lambda function can run many times in the same Linux container, or as the scale up happens, it will start firing up more and more Linux containers. But previous to Nitro, this was actually quite a heavy process and involved having to set up network adapters and do a bunch of different things. And for a long time, people would talk about the Lambda warm-up problem. However, that problem's been addressed with Nitro, where Lambda containers are simply fired up on the super lightweight Nitro KVM system. And you can actually see a really good demonstration of how that works in the Warner's keynote from reInvent 2019, where he gets another speaker up on stage to talk about Nitro and Firecracker and how Nitro has really helped speed up Lambda execution time. It's gotten rid of that Lambda warm-up time, and about how Lambda containers or Linux runtimes is not really a container, how they're spun up, reused, and then shut down, and so on and so forth. So hopefully that answers your question.
Very good. Okay, that brings us to time. So that just leaves me to say thank you ever so much to you, Samuel, and thank you to everybody who joined today's session. I really hope you found it useful. You'll find that the slides and the video will be made available in the coming days, and we'll send out a note to everybody with that. In the meantime, if you want to get in touch with us, you can do so just by return email. Otherwise, we wish you a good day and look forward to seeing you on a future session. Bye for now.
Thank you.